students, good morning. Welcome to another session of Vedantu Karnataka. This is Catherine, your physics master teacher. So quickly, let me also check. Let me know if I'm visible and audible. Students, good. Yeah, I can hear myself. I think half my face is cut. Okay. How are you all? Yes, it's a Saturday, and I think most of them are sleeping. Where are my students? Join quickly, all of you. Yes. Can you all? Hi, good morning, RXBTCC. I think it's good afternoon right now, no? 12, but still, it's okay. Mm, I'm doing good. How are you doing, RXBTCC? How's your classes going? Did you all, when are your first exams coming up? Are you all prepared? I mean, what a question, right? Have you all started preparing? We've started our work to help you prepare. Yes. Okay. So quickly let me know in the chat, students, how you all are doing and what's happening. Let's just wait for 1 minute and then we'll start. Quickly share the link to all your class groups, all your friends, ask them to join. Today we are going to do the final part of motion in a straight line. With today, motion in a straight line is done and dusted. Okay? So I've done classes as 3 parts so that you don't get bored. So if you watch all these 3 parts, you're good to go for your second chapter. Motion in a straight line. Okay, so last class, what all did we discuss? So students, if you want to, type messages in the live chat, you have to subscribe to the channel. Okay, so please do subscribe to the channel and interact with us. And if you are someone who's looking for an offline class and you're from Karnataka, we have our offline center at JP Nagar. Okay, so you can just, book a slot, go visit them, tell them what you are looking for. They will tell you what they can provide. And if you're impressed, you can definitely join. Yes, I'm sure you will be impressed because we have the best faculties, we have the best facilities, everything is the best. If you're looking for JEE, NEET, KSET, or 8 to 10 foundation, anything, you can approach us. Okay, so let's look at what we did in the last class. Quick recap and then start with today's portion. So today I'm going to start with graph analysis. So before we move on to graph analysis, what did we do in the last class? We derived the equations of motion by graphical method. So I did the derivation of all the 3. Yes. So you can just watch yesterday's lecture. You will get to see all this. Okay. Ma'am, is this NEET level? I'm not going to do NEET level questions, but the concept and the theory is NEET level, JEE level, whatever, any exam or your PU also you can use this. Okay. But for NEET, you need to practice questions as well. That I'm not going to do in these lectures. These are only theoretical lectures with some questions in between. Okay. So the theory part, whatever exam you go, this is the theory that you want. Hi. You're back. Hi, Uday. Okay. So today we will be continuing with these graphs. So what are we going to look at? We're going to look at graph analysis. Now, what is graph analysis? Graph analysis is how we can analyze graphs. For example, if you have a position time graph, okay? Let me draw that. First, x-axis, y-axis. So basics on graphs, what comes on the x-axis, what comes on the y-axis, all that I discussed very detail in the last class. 1, 2, x-axis, y-axis. Okay. So on the instead of x-axis, y-axis, what I'll write here is I will write position and time. Okay, so this is time t, and here this is position. Position, okay, X. Now we will draw a line on the graph. We'll draw a line on the graph. We'll just draw a straight line. A straight line. Now what does this mean? This means that if this is a graph for a car, okay, if this is a graph for you driving a car, what does this mean? In the first, let's put time in seconds, okay? So in the first 5 seconds, you are in front of your house. That's your position. In the next 10 seconds also, you are in front of your house. 20 seconds also, you are in front of your house. After 1 hour also, you are in front of your house. That is why you get a straight line. Why? Because position is a constant. It's not changing. What does that mean? That means you have not started your car. You are not driving. You are at rest. You are not moving. You are a stationary object. You understand that? Okay. So since position is not changing, but time is changing, that means you are somewhere at rest or you are stationary. Okay. So a position time graph for a stationary object is what we have drawn here. So this is a position time graph for what kind of an object? For a stationary object. So now if the question is draw the position time graph for an object that is at rest, you just draw a graph with position on the y-axis, time on the x-axis, you draw a straight line. That's all. Okay. Now let's find out the slope. All this we discussed in the last class on what is slope and all that. So please do watch that before watching this if you are watching this first. So let's find out the slope. So slope is tan theta as we discussed. Now what is the angle here? It's just parallel. So the angle is 0. So tan 0 is 0. Okay. Now as I discussed in the last class, what is slope of a position time graph? Slope of a position time graph gives us what? It gives us what? It gives us velocity. We discussed that in the last class. Slope, yeah. See? Slope of a position time graph. So position is the same as displacement, distance, all that. Position time graph gives velocity. What is slope? Change in y-axis coordinates divided by change in x-axis coordinates. Okay? Yeah. So slope of a position time graph gives you velocity. Okay. Now here what is velocity? It's the slope. So if slope is equal to 0, that means slope is equal to 0 means velocity is also equal to 0 because the slope of a position time graph gives you velocity. Alright. So if velocity is 0, the object is not moving. So that means that the object is at rest. So that means that the object is at rest. Okay. Now let's see how we do that. We'll just draw the graph. Now if I find out the area under the graph, okay, if I find out the area under the graph, what do I get? So here, the area under the graph is again distance into time. So here, it just represents nothing. You have nothing to get here. Area under the graph represents nothing and slope is change in position by change in time, which is 0. So this is the analysis for a graph, which is a position time graph of a stationary object. Is that clear? Yeah. What reply you they? Yes, yes, I know you there. You come to every class. Hi, Sharmila. Is this clear to all of you? Next. Next, we are going to analyze another graph, which is the position time graph for uniform motion. So, it is a position time graph for what kind of motion? For uniform motion. So, in the last class, I've already taught you what is uniform motion. So, all of you quickly tell me what is uniform motion. In the chat, let me know what is uniform motion. I'm going to draw the position time graph for uniform motion. Yes, uniform motion is when a body moves equal distance in equal intervals of time. So, for example, if you are walking from home to school, every 5 minutes you keep covering 2 meters. Then you are walking with a uniform motion, which means you're walking with the same speed from your house all the way to your school. Okay? Yeah. So let's look at the position time graph for uniform motion. So first you need an XY axis and an X axis. So on the axis, what should you write? It should be time, and Y axis should be position. So that's why it's called a position time graph. Now since it's uniform motion, so see, since it's uniform motion, if this is 2 and this is 2 and this is where you are, then when this becomes 4 and 4, this is where you should be. Now when it becomes 6 seconds and you should cover 6 meters. So the graph will be like this. Do you understand? So this is, it could be any value. Okay. Let's say here the values are 1, 2, 3. Okay. So in 2 seconds, if you cover 1 meter, then in 4 seconds, you should cover 2 meters. Then in 6 seconds, you should cover 3 meters. So this is how the graph is going to be. So the graph will be like this. A straight line, a linear graph. You understand that? Okay. Right now, so here again, position time graph. What is the slope of a position time graph? Slope of a position time graph is velocity. As we already discussed, it's velocity and it is also equal to tan theta. And this will be not zero, but it will be a constant value. Okay, it will be a constant value. So in uniform motion, we've already learned that the object should move with the same speed or the same velocity. So the slope of a position time graph, which is position by time, is going to give you velocity or speed. Yeah. Now that will always be a constant. That is a proof here because slope is a constant. So see, as I said, okay, let me explain that in case. So imagine you're walking from your house to school. Every 2 meters takes 5 minutes. Okay. So what is your speed? Your speed is distance by time, 5 by 2. Next 2 minutes, again you take 5 minutes, same speed. Next 2 minutes, you again take 5 minutes. Sorry, next 2 meters, you again take 5 minutes. So every 2 meters, you take 5 minutes. So every time your speed is the same. So if you plot that on a graph, wherever you find the slope, you should get the same value because your speed is same throughout. So that from this graph, you can see that if you take tan theta, it will always be a constant. And this means it has uniform motion. Okay. Now, how do I prove that from the graph? Now, let's say I take this angle. Okay. This angle is theta. Otherwise, if I take this angle is theta, or let's say I take this angle. See, what is tan theta? If you have a line, the angle it makes with the x-axis is theta, and tan theta is your slope. So this could be the angle. If this could be the angle, this could be the angle. You can take any angle. Okay, it does not matter. So whatever angle you take, it's going to be a constant. For example, let's take black. Okay. So first, if if it's 0, tan 0 is 0. If it's 30 degree, if the angle is 30 degree, tan 30 will be 1 by root 3. If the angle is 45, tan 45 will be 1. If the angle is 60, tan 60 is root 3. Now, if the angle is 90, tan 90 will be infinity. Now, if the angle is 90, then it won't be uniform motion. But anyway, it is giving you a single constant value. So, whatever angle you take, it's always a constant. Okay? Yes. This is the position time graph for uniform motion. Okay. Next, we look at the position time graph for accelerated motion. Okay. Accelerated motion means the body has to accelerate. It has to move faster and faster. So let's do that. First, again, you draw the axis. So here, again, this is also position time graph, okay, for accelerated motion. So I will put distance or position, it doesn't matter. Distance with respect to time. Now let me draw the graph. The graph will be something like this. Because at less time, more speed should be covered. Only then it's accelerating. That is why at less time, more speed. Hi Chetan Kumar. How are you? Welcome to the class. Now, if I take point A, okay? Now, if I take point A makes an angle alpha with a time axis. Now, if I take another point B is going to make an angle beta with the axis, okay? So, since it's a curved line, I have to take the tangents. That is what I am doing here. Now, here, the slope is d by t, which is equal to velocity, and you can see the slope is increasing. So when the slope is increasing, what happens? Velocity is increasing. When velocity is increasing, it means the motion is accelerated motion. Now, how did I know the slope of velocity is increasing? We just look at alpha and beta. So here you can see, obviously, beta is greater than alpha. Beta is at a bigger angle compared to alpha. Now, these are all angles less than 90 degree. These are all acute angles. Oh, my proportionality and alpha looks the same, no? It's not proportionality, it's greater. Beta is greater than alpha. Okay? So, for acute angles, that are angles where theta is less than 90 degree, tan beta should also be greater than tan alpha. What is tan beta? Tan theta is slope. So tan beta is also slope of beta. Tan theta is slope of m theta. So tan alpha should also be slope of alpha or a. Okay, I will just put this as, since beta is the angle representing b, it is the slope of b. Alpha is the angle representing a. So m is the slope of a. So you will get MA greater than MB. Sorry, MB greater than MA. Okay? MB greater than MA. So which one has a higher slope? Point B or point A? Point B has the higher slope compared to point A. So if point B has a higher slope, it means point B is at a higher speed or a higher velocity. Why is point B at a higher velocity? Because slope is the same as velocity for a distance time graph or a position time graph. Now, what does this mean? This means that imagine you are here, okay? At 0, 0, you are driving a car. When you reach point A, you have some velocity. Now, when you reach point B, you have more velocity. So, you have accelerated, okay? So, that is accelerated motion. Is this clear to all of you? Can you quickly let me know in the chat if this is clear? Yes? I want you to understand the concepts here. Yeah? Madhyana Ashamsakal. Same to you. Madhyana Ashram Circle to you also. Chetan Kumar. Is this clear? Yeah. Okay. Now let's look at the next graph, which is a graph that's representing retarded motion. So retarded motion is just like deceleration. Acceleration is increase in velocity with respect to time. Deceleration is decrease in velocity with respect to time. So what should happen to the slope? The slope, or it could be speed or velocity, okay? The slope or the speed should decrease. Okay, so this will mean decelerated motion. Decelerated motion. So acceleration will be less than 0. Not necessarily. Let's not do that. This just means decelerated motion. Now let's draw the graph. Where is the graph? So x-axis is time, y-axis is position. Okay, x-axis is time, y-axis is position. Now my graph, since it's deceleration, initially the speed should increase and then the speed should decrease. Okay, so I'll take 2 points, point A and point B, and then I'll draw 2 tangents. Let's take the tangent. This is tangent due to A. This is tangent due to B. A is alpha, B is beta. Now, you can clearly see here, alpha will be a bigger angle, beta will be a smaller angle, right? Because, see, if there's something like this, imagine this is A, alpha, and then the second one is like this. Which one will have a higher angle? So, okay, imagine this is the axis, this is alpha, and this is beta. Beta is more tilted, so it will have a smaller angle. So here you can clearly see that orange. Alpha is greater than beta. So obviously tan alpha should also be greater than tan beta. Now what is tan alpha and tan beta? Slope of A and slope of B. So M greater than B. So what happens? A has a higher velocity or a higher speed. B has a lower one. So this means that the slope is decreasing. Red. Decreasing slope. Okay? Do you understand that? Is retarded motion clear to all of you? Okay. I hope it's clear. So acceleration will be reducing. Okay? It will be reducing. Now, some of you might be wondering, ma'am, sometimes I'm putting speed, sometimes I'm velocity. Why? See, the only difference between speed and velocity is speed with direction is velocity. Okay? So, if I'm just driving my car and the direction is not necessary, I can say I'm moving with a speed of 5 meters per second. Now, if the direction is necessary, I say I'm moving at the velocity of 5 meters per second in the forward direction. Basically, speed with direction is velocity. Okay? Yes. I hope this is clear. Let's move on to the next graph. Next are some more displacement time graphs. Okay, let's look at some displacement time graphs. Okay. Okay. First, this is time. Displacement is represented by the alphabet S. Now I'm going to represent a line like this. Okay, this is point A, this is point B. What does this mean? What will the slope be here? Obviously, it's a parallel straight line, so the angle is going to be 0. So slope will be tan 0, which is 0. So this is a displacement time graph. The slope of a displacement time graph gives velocity. So velocity is 0. This means that the object is at rest. So you might be wondering, ma'am, you already did this. There it was position time graph. This is displacement time graph. Same thing, but the only thing is displacement on the y-axis. Okay, now let's draw one more graph. Again, displacement time. But this time I will draw a graph that is like this. A straight line graph, okay? So you should tell me what it means. A line graph like this. What does this mean? This means that there's just one angle, and that's theta, and this angle is definitely a constant value. Okay. So slope is a constant. Slope is a constant. If slope is a constant, velocity is also constant. Now, if velocity is constant, what happens to acceleration? Quickly, tell me what happens to acceleration. See, velocity constant means, as I said, if I'm driving a car, initially my speed is 20. After 1 hour also it's 20. After 5 hours also it's 20. It's just keeping on. I'm just driving at 20. That means I'm not accelerating at all. So when velocity is constant, acceleration is 0. So students, I want you to understand these terms because these are very important terms. So in my first lecture of straight line in a motion, I've explained clearly what velocity, speed, acceleration and all is. Okay? Okay. Now I will draw one more graph. Again, displacement time. So this time I will take a graph like this. So here you can see in very little time, a lot of displacement has been covered. See, you can see here the time is not changing, but you're covering a lot of distance. So in very little time, you're covering lots of distance or displacement. So that means the slope. So that means the slope is increasing. Velocity will also be increasing. Velocity will also be increasing, and this means it has accelerated motion. Okay, so when velocity increases, obviously the motion is accelerated. Okay, yeah, this represents acceleration. Okay, done. Are all these three distance time, displacement time graphs clear? Now there are some more. These are mainly enough for you. Sorry. Hi Sanjana. Hi Preetu. Welcome to the class. We're discussing graphs. Okay. Yeah. So there are again we can also look at some more graphs. Time, displacement, time and displacement. And if I put a graph like this, okay, then this graph represents decreasing slope. So this graph represents decreasing slope. Decreasing slope. So velocity is decreasing. This means retarded motion or deceleration. Retarded. Okay. Okay. Now imagine if I'm drawing a graph like this. Okay, so if it's coming down, if it's a straight line down, then this is negative constant velocity. If it's going up, it's positive constant velocity. This is negative constant velocity. Okay, what does negative constant velocity mean? It's going back to its original position. So imagine you're going from home to school, but then you're coming back from school to home. Then this will be your graph. Okay. Okay. Now let's move on to the. Okay, so these are all some displacement time graphs. Just a second. Be back. Okay, let's move on to some velocity time graphs. Yes, are you all ready to draw some velocity time graphs? Okay, quickly let's do some velocity time graphs. So again, velocity time graph will also be same kind of graphs, but the only difference is the slope is going to be different. So before I draw it, quickly tell me what is the slope of a velocity time graph going to be? This is velocity, this is time. If I draw a straight line like this, what is its slope going to be? Quickly, let me know. Its slope of a velocity time graph is going to be acceleration, and it is going to be equal to 0. Okay. Next velocity time graph, velocity time straight line like this. Straight line. Yeah. So this is going to be slope here. As I said, it has a single angle. So slope is going to be tan of theta, which is going to be constant. So here slope is acceleration. So acceleration is going to be constant. Okay. Now, if I take the area under a VT graph, what will I get? Now, if I take green, so if I take area under, so if this will make a triangle, right? So this will make a triangle like this. So if I take area under VT graph, from this single graph, I can get displacement also. Okay. So slope is a constant, area is a acceleration is a constant. The area under will give me displacement. So this much of data you can get from a velocity time graph. Okay. So all these things you get from a velocity time graph. Next. Okay. So same thing. Some of you might be wondering, ma'am, what if initial velocity is not 0? So right now here initial velocity is 0, right? If initial velocity is not 0 and it's like this, this will make an angle theta with the x-axis. So this is also going to be a constant. So here also acceleration is going to be a constant. Do you understand that? Okay. So these are 3 main velocity time graphs. There are some more which also we will discuss. But these are 3 basic velocity time graphs. Okay, let me draw them under here. The next velocity time graph is velocity time so here this is increasing acceleration. Okay, you can see the speed increases with very little time. Next one, where should I draw it? Okay, I'll just draw it here. It is decreasing acceleration. Then okay, one second. Yeah. So this is u, initial velocity. Okay, v. This is the initial velocity. This is the final velocity. So obviously, it's going from a high velocity to a very low velocity. So here, v is 0, isn't it? High velocity to low velocity. So this is negative acceleration. Okay, this is negative acceleration. Why negative acceleration? Because initial velocity is high. It is u. Final velocity v is 0. So what happens to acceleration? It's basically decreasing. Okay. So these are all some velocity time graphs. Draw shapes. Okay. Yeah. So these are some velocity time graphs. You can quickly take a look at these. I will move out of the screen so you can see properly. Yes. So there are 4 velocity time graphs that represent acceleration 0, acceleration constant, again acceleration constant, increasing acceleration, decreasing acceleration, and the last one shows negative acceleration. Okay? Is this clear to all of you? These are all the different velocity time graphs. Okay. Now let's continue. Let's look at the next set of graphs, which is acceleration time graphs. Okay. Acceleration time graphs. Okay. Acceleration time graphs. Let me just use the same color. Violet. Okay. Time acceleration. So first graph, you all know what is a graph. It's going to be a straight line. Now, what does this represent? Does this represent an object stationary, object rest? What does this represent? So slope of an acceleration time graph represents obviously change in acceleration by change in time. Change in acceleration by changing time is not going to give you anything. So it gives nothing. Okay. Then next is area under acceleration time graph. Let's write that also. Area under acceleration time graph. Okay. So area under acceleration time graph represents, what is it? This will become a rectangle. So this will become acceleration into time. So that is going to be delta V, isn't it? Because we know A is equal to V minus U by T or delta V by T. So from this we know the area under the graph is going to give you delta V. Okay. So here obviously the slope is constant. So what happens? Here slope is constant. Sorry, slope is 0. Slope is 0. Slope is 0. So since slope is 0, acceleration is a constant. It's not going to change. So whatever value, if you have 5, then throughout all the time, the acceleration is going to be 5. Okay, let's draw another graph. Time, acceleration. This time, It's a straight line, okay? There are wiggles on my line. That's because I'm not using a scale. It's a straight line. Here what happens? Acceleration is increasing, okay? So this graph shows increasing acceleration. Now if you take the area under the graph, you will get change in velocity. That's all. Slope is not going to give you anything. Next graph. Oh. Next graph. Next graph is a little different, but yeah. This you wouldn't need for your PUC, but if you're looking for competitive exams and all, it's good if you can understand this. So this is a graph, okay? There's 1, 2, and 3. 1, 2, 3 should be of the same size. It's my pure drawing. So here, acceleration keeps on changing. So acceleration is variable. So which means the velocity, okay? Velocity delta V will be acceleration of 1 minus acceleration of 2 plus acceleration of 3. Why? Because 2 is in the other side. 1, 2 and 3. And speed will be, okay, so speed will be acceleration of 1 plus acceleration of 2 plus acceleration of 3. Why is the difference there? Because 1 and 3 are in one direction, 2 is in the opposite direction. So when you're calculating velocity, okay, so when you're calculating velocity, directions are important. So A1 and A3 are positive, A2 is negative. But if you're calculating speed, direction is not important. It's only magnitude that matters. So acceleration of A1 plus acceleration of A2 plus acceleration of A3. That's all. Okay. Yes. Okay. Is that clear? So these are the 3 acceleration time graphs. So the first 2 graphs are very important. The third graph is just a general graph. I mean, it could be any shape. So if there, whatever shape you take, acceleration is always the area, I mean, velocity is always the area under the acceleration time graph. Okay? Yes. Okay, let's continue. Let's continue. Let's continue. So now we looked at displacement time graph, we looked at position time graph, we looked at displacement time graph, we also looked at velocity time graph, we looked at acceleration time graph. Okay, so these are all the basic graphs that you need to know. So with that, we put an end to the concepts of graphs. So we used graphical method to get equations of kinematics. We learned about slope, we learned about area under the graph and all of that. Okay. So half of it was done in last class, half of it was done today. Now today we are going to start one more, the final concept in the chapter, which is the concept of differentiation. Okay. Concept of differentiation. So in your first PU and second PU, yeah. So in your first PU and second PU, you will need differentiation and integration. So in simple concepts, what is differentiation? What is integration? Let's look at that in today's class. And we will also look at the mathematical formulas and all of that for differentiation and integration. Okay. So okay. So differentiation is basically, it tells you how fast something is changing. Okay. Whereas integration tells you, gives you small elements, you add up them to get the whole big element. Okay. I know you didn't understand anything, but we'll look at it in detail. Okay. I'll tell you what is differentiation and what is integration in very detail. So differentiation deals with different concepts. Okay. Like slope of a graph. So whenever we want to find out the slope of a graph, okay, dealing with slope of graph. Next, differentiation is also considered when you take a very small element or taking very small element or for finding the maximum and minimum value of some quantity. For finding maximum or minimum value of any quantity. Okay. Now it can also be used for two continuously varying quantities. Two continuously varying quantities. Okay. So the concept of differentiation can be applied in different scenarios. So first we will see how it can be applied for a slope of a graph. Okay. So if this is my graph, this is my x-axis, this is my y-axis. Okay. And let's say this is my graph. Okay. Now what I'm going to do is I'm going to take the slope. Okay. So I'll take the slope of the graph. Let me do it in green. Okay. Yeah. I'm going to take the slope of the graph. And the slope is going to be what? Change in y-axis coordinates divided by change in x-axis. We learned this in the last class. Okay. Now, imagine my x is very small. Okay. So if delta x is very small. Okay. If delta x is very small, what does that mean? That means this part is very small. Okay, let's say it's the green line that I drew, that's very small. That delta x part, the change in x, the two x coordinates are very close together. So if delta x is very small, they're very small such that they're almost zero. Okay, so I'm going to say delta x tends to 0. Then what you can say is, limit when delta x tends to 0. What does when delta x tends to 0 mean? When you find the slope, the value of x is very small. When delta x tends to 0, delta y by delta x, which is the slope, will be equal to dy by dx. What does this mean? This means that the slope of a graph, if it's very small such that the delta x term is almost 0, then it gives you dy by dx, which is a differential. So what is differential? Differential is a very small quantity. Okay. So when can I say it is differential? When the slope is very small with respect to x. Do you understand this? Yes? No? Okay? Yes. Just a second. Okay, let's not. What's happening? Okay? Did you understand the students? So if you have a graph and the x part, the delta x part, if it's very small, such that it's almost 0, then you can say it is equal to dy by dx. Now, what is dy by dx? So, dy by dx is the differentiation of y with respect to x. Okay? It is the differentiation of y with respect to x. It can also be called as the rate of change of y with respect to x. Okay, so limit delta y by delta x. It's a very small quantity that is going to give you your differentiation. Differentiation is basically rate of change of y with respect to x. Okay, is this clear? Yes. Now let's do a question. Let's do a question. So I have a graph, okay, and let this be the graph, okay. So now what can I say? I can say that the slope is equal to dy by dx. Now you have a new formula for slope. Slope is dy by dx. Yes, this is x, this is y. Now how do I find dy by dx? So there is a basic formula for differentiation, which I will teach you right now. So the basic formula for differentiation is that d by dx of, instead of y, whatever term you have, let's say you have x raised to n. Okay, instead of y, I put a x raised to n. So if you differentiate it, what you will get is n into x raised to n minus 1. So this is the basic formula for differentiation. It's a very important formula as well. Now in your mathematics, you will learn on how this formula came. Okay, so in mathematics, you will learn about the formula and how this formula came and all that. But I'm a physics teacher, so in physics perspective, you don't need all that. You only need to know how to apply the formula. That's all that you need to know in physics. Okay, so you need to know that the basic formula is dx raised to n by dx is equal to n into x raised to n minus 1. Now let's do some questions so that you understand the basic formula. Okay, so first question. Question number 1. Solve d by dx of x cube. Okay, so this is the question. So instead of y, I have x cube. So it's very easy. I have to apply the basic formula. So this is going to be equal to n. Here what is n? 3 into x raised to 3 minus 1. So this is going to be equal to 3x square. You understand? So the differentiation of dx cube by dx is 3x square. Let's do another question. We'll do so many questions, so it's fully clear to all of you. Next question. dx raised to 7 divided by dx. So this is going to be equal to 7 into x raised to 7 minus 1, which is 7x raised to 6. Okay. Now next question. d by dx of x raised to 3 by 2. How do I do that? 3 by 2 into x raised to 3 by 2 minus 1. So this is going to be equal to 3 by 2 x raised to 3 by 2 minus 1 is how much? 1 by 2. So this 2 goes here. 3 minus 2 by 2. 3 minus 2 is 1. 1 by 2. So this is going to be equal to 3 by 2 x raised to 1 by 2. Okay. Next question. d by dx of x raised to minus 7 by 2. So this is equal to minus 7 by 2 into x raised to minus 9 by minus 7 by 2 minus 1 minus 9 by 2. Okay. Next question. d by dx of 2x square. So how will I do 2x square? So 2 is a constant. So constant you don't differentiate. Okay. So if you have constants, you just leave it. You don't differentiate it. So you take 2 outside. This becomes d by dx of x square. Now you can do it. Now 2 is still there. X square is 2x raised to 1. So the answer will be 4x. You understand that? So whenever you have constants, to differentiate constants, you just take it out. You don't differentiate constants. Okay? Now, let's try out more examples. Now, imagine I have d by dx of 1. So, d by dx of 1 is how much? 1 means what? 1 means d by dx of x raised to 0. What is 1? X, anything raised to 0 is 1. So, x raised to 0 is 1. So, 0 into x raised to 0 minus 1 is 0. Okay. So, from this, we can get a general formula. What can we say? We can say that differential of any constant, okay, even if it's 2 or 5 or differential of any constant by dx will be equal to 0. Okay, this is our general formula. Differential of any constant by dx is equal to 0. So these you need to know when you're doing problems. You need to know all this. Next, d by dx of x. Okay, d by dx of x. What is x? X is x raised to 1. Okay, so this is 1 into x raised to 1 minus 1, which is 1 into x raised to 0. X raised to 0 is what? 1. So 1 into 1 is 1. Okay, so now the next identity that we have is dx by dx is equal to 1. Okay, see, it could also be d of t by dt could be 1. D of s by ds could be 1. See, you can take any identity. It could be anything differential with respect to the same thing. For example, differential of time with respect to time. Differential of displacement with respect to displacement. Anything is 1. Next, I'll teach you two identities also. So, differential of sin x. You all know what sin x is. Divided by dx is always going to be the opposite, which is cos x. Okay. Next is differential of cos x with respect to dx is always going to be minus sin x. Okay. Differential of sin x and cos x. It is going to be opposite. Is this clear to all of you? Okay, so some of you might be wondering, ma'am, how are you getting all these formulas? So that will come under mathematics. In your math lessons, you will learn the derivation of all of these formulas. So in physics, you don't need those formulas. I mean the derivations. You need the formulas, but you don't need the derivations. So I'm not going to go into the derivations because you have a lot of other important things to learn here. So this part will come in math. Okay. So all these things, all these identities that are put in boxes are very important. Okay. These are all very important. Is this fine? So differentiation gives you a very small element or the slope of a very small element. You get differentiation. Now we look into what is integration. So my screen is only... Okay, so this part of my screen, is it not visible? Is this clear to all of you? Quickly put some fire emojis in the chat if this is clear to all of you. Yeah. Okay. Yes. Chat. Okay. Next. Next we will learn the concept of integration. So this is the concept of differentiation. Now we'll learn the concept of integration. Let's look at the concept of integration. Oh, too thick. Concept of integration. Okay. So what is the concept of integration? Now, if you have, let's say I have a graph. Okay. Both I'll explain in terms of graphs. If you have a graph, okay, and this is the x-axis, this is the y-axis, and let's say this is my graph. Okay. So that is my graph. One second, students. Yeah, this is my graph. Now, I need to find out the total area under the graph. So this is an irregular shaped graph. So I can't use any mathematical formula. It's a curve, right? I can't do area of triangle, area of rectangle. I can't do any of that. So what I will do is I will take a small element. Okay, so I'll take this small area. Okay, so I'll take this small area and I'll find out the area under area of the strip. I'll find the area of this small strip. Now, what will the value of that area be? That will be equal to dA. So, if the area of a full green, if the area of the full graph is A, then the area of the small part, I will just take it as dA. Okay, and dA will be equal to, what is it? So the small area element, it will be dx. Okay, but along y it has some, so it will be y. So dA will be equal to side into side, so it will be y dx. So you can see this slant is very small, so you can just take it as a straight line because I'm taking a very small element. See, if this is my curve, I'm taking a very small element. So this slant I can ignore it. I can just take it as a rectangle. So the length element is some value of y. So whatever value, so this particular value of y. And the x element is a very small element, so I'll just take it as x. Okay, so I will get dA is equal to y dx. This is the slope. Okay, now to find out the total area under the graph. Okay, to find out the total area under the graph, you have to take so many strips like this. So if you can divide it into 100 strips, you have to find out the sum of areas of all the strips. You have to find out the sum of areas of all the strips together. Now that is a tedious task. Imagine I take 100 strips and I keep calculating the area of all the 100 strips. I will not finish calculating my area in a day. So instead of that, there is a shortcut. So what you can do is you can just take the integral of the area of the single strip, which is dA. So the integral of dA is going to give you the area of the whole strip. Okay, so that is what is integration. Now, if you have a big circle and you know the area of one small part, if you integrate that small part, you will get the area of the whole circle. See, beautiful, no? It's like magic. That is integration. So now what will area be? Area is basically the integral of dA. The integral of dA is the integral of y dx. You understand that? Okay. So the full area under the graph is basically the integral of one small area element. Now what does integral of y dx mean? It means that integration, so this means integration of y with respect to x. Okay. It means integration of y with respect to x. So if I have a dt, it means integration of a with respect to t. So this means integration of y with respect to x. Now, now dx is what? Dx is the area under the yx graph. Now for integration also, just like differentiation, there is a general formula. Okay, let's look at that. So general formula. So general formula would be integration of x raised to n with respect to dx is equal to x raised to n plus 1 divided by n plus 1. So remember the formula for differentiation. What was the formula? For differentiation it was d by dx of x raised to n is nx raised to n minus 1. So here it is addition and division. There it was subtraction and multiplication. Okay, so this is the general formula for integration. Now let's apply this and do some questions. Let's do some questions. For questions, let's take blue. Okay, first question. Integral of x cubed dx. What will the integral of x cubed dx be? X raised to 3 plus 1, the whole divided by 3 plus 1. So it is x raised to 4 by 4. Okay. Next question. Integral of x raised to 8 dx. It will be x raised to 8 plus 1, the whole divided by 8 plus 1, which is x raised to 9 by 9. Okay. Next question. Integral of x raised to 3 by 2 dx. X raised to 3 by 2 dx will be x raised to 3 by 2 plus 1, the whole divided by 3 by 2 plus 1. So this is going to be equal to 2, 3, 4, 5, right? So x raised to 5 by 2 divided by 5 by 2. So this can be written as 2 by 5 x raised to 5 by 2. Okay? Next question. Integral of x raised to minus 7 by 2 dx will be x raised to minus 7 by 2 plus 1, the whole divided by minus 7 by 2 plus 1, which is x raised to minus 5 by 2, the whole divided by minus 5 by 2, which is minus 2 by 5 x raised to minus 5 by 2. Is this clear? These are all some questions. Now we will look at some constants. So integral of x raised to 1 dx is what? In the previous case, differential of x raised to 1 was what? Quickly tell me. So integral of x raised to 1 will be 1 plus 1 divided by 1 plus 1, which is x square by 2. Okay. So integral of x raised to 1 is x square by 2. Now if you have integral of 1, okay, so the integral of 1 dx is what? Integral of 1 is basically x raised to 0. So this will be x raised to 1, 0 plus 1 divided by 0 plus 1, which is x. Okay, so simply integral of dx is x. Integral of dx means what? Integral of 1 dx. Okay. Integral of 1 dx or integral of dx is x. Very important identity. Next is integral of dt. If you just have dt, it means integral of 1 into dt. That means integral of x raised to 0 dt. No, not x raised to 0. T raised to 0. T raised to 0 dt. Why t? Because it's with respect to t. So this is t raised to 1 by 1. So this is t. So next identity, integral of dt will be t. Okay. So integral of ds will be s. Like that. Is this clear? So these are all some identities for integration. Okay. Is this clear? Now one thing you need to remember is whenever you integrate something, you have some constant added to it. Okay. So if you have integral of s cube by, so what you should do is, you should always put a plus c. Okay? Because this integration is not giving you the full value. So the integration will always be plus c. So whatever integration you do, you should put plus c. Okay. So whatever integration you do, you should put plus c. Why? Because I mean, why in detail, I'll explain it to you. Whatever you integrate, you don't get the full answer there. So whatever answer you get, that plus some constant value is your full answer. Okay. Now let's see why. Hi Samarth. Hello. Welcome to the lesson. Now there are two different kinds of integrations. Okay. The first type is indefinite integration. Okay. Indefinite integration. And the next one is definite integration. Okay. Now what is indefinite integration? Let's take a graph. Let's take a graph. Okay. Let's take a graph. Let's say this is my curve. And this is 0. This is some value x1, any value. Okay. Now if I take this part of the graph, okay, so I'll take a parabola so I know what the graph represents. Okay. So now, this part represents y is equal to x square. Okay, so this part represents y is equal to x square. So let's integrate it. So it is integral x square dx. So what is integral of x square? X cube by 3, but plus c. Because you don't say the limits, you don't say from where to where it is and all that. So to complete this full equation, you need a constant. But what about a definite integral? A definite integral is an integral which has limits. For example, x square dx. Okay, x square dx, and I say the minimum value x can have is 0 and the maximum value x can have is 1. Okay, so what is 1? It is the lower limit of x, which is a maximum, which is the minimum value x can have, and 1 is the excuse me, yeah, 1 is the upper limit of x, which is a maximum value x can have. So now let's differentiate it. So this is, sorry, let's integrate it. So this will be what? X square by 3, x cube by 3, x cube by 3, x2 plus 1 divided by 2 plus 1, x cube by 3. So this is going to be from 1 to 0. Now the next step is a new step to all of you. So what we're going to do is we are going to apply the limits. So we are going to apply, it's always upper limit minus lower limit. So first, the maximum value x can take is 1. So let's substitute that. So this becomes 1 cube by 3 minus the minimum value x can take is 0. So 0 cube by 3. 0 cube by 3 is 0 itself. So this becomes 1 cube by 3 is 1. 1 by 3. So that is your answer. Now this is a definite integral. You know exactly from where till where you have integrated the x. You know the limits. But for a question where you don't know the limits, there could be additional terms. So that is why you always add a c. Now in the previous case, nowhere we put limits. So that is why everywhere we put a c. Okay. Now I can show you one more question. So let's say integral of x raised to 5 dx. Let's put the same limit. Okay. 0 to 1. I can put any values. I can put 10 to 15, 20 to 25, any values. So this will become x raised to 6 by 6 and then 0 to 1. Okay, this is just another way in which you can do it. So what you can do is you can take 1 by 6 outside because it's a constant. The limit applies only to the x term. So this becomes 1 by 6. What is x raised to 6 with respect to 1? 1 raised to 6 minus 0 raised to 6. So this is 1 raised to 6 by 6, which is 1 by 6. Okay. So you can apply limits in both ways. But you should apply the value of limit only to the x term. Is this clear? So this is definite integration. So whenever you do definite integration, you have limits. So you need not put constant. But whenever you put indefinite integration, you need to put the constant. That is because you don't know from where to where your x is going. So you always put plus c. Okay. Next is the final and important part. So why did we learn all these integration and differentiation? Now you will know. Because what we are going to do, we are going to derive equations of motion using these. Okay. So now we are going to derive the equations of motion. So let's do that. So with that, we are going to wind up today's class. Okay. So last topic of the lesson, to derive equations of motion. So we all know velocity is what? Velocity is the slope of a distance time graph. The slope of a distance time graph, we've now learned that it's going to be ds by dt. So earlier it was delta s by delta t. So now if it's a very small quantity, v will be ds by dt. Now what we're going to do is we're going to cross multiply. So v dt is going to be ds. Now I'm going to integrate. So integral of ds is equal to integral of v dt. So what does this mean? This means that initially I took a small element. ds is a small part of the full graph. Now to find out the full graph, I have to integrate. Now what will my limits be? So the minimum displacement a body can go is still 0. Let's say the maximum displacement is s. Okay. Now if you have numbers, you can put them, but generally I'll put it as s. ds is equal to, this is with respect to dt, so it should be with respect to time. So what is the minimum time a body can have? 0. Maximum time, I'll take it as t, v dt, v dt. Now here, using first equation of motion, okay, using first equation of motion, I can write 0 to s ds is equal to integral of 0 to t, v is what? U plus at into dt. Okay, instead of v, I will write it as u plus at. Now let me split the terms. 0 to s ds is equal to integral 0 to t u dt plus integral 0 to t at dt. I have just split the terms. Okay, is this much clear? Now what I will do, I will integrate ds. What is the integral of ds? This is why the earlier part was important. What is the integral of ds? It is s. Yes. So integral of ds is s. So s with the limits 0 to s. Now if these limits were not there, it becomes s plus c. But here we have limits. So no s plus c. So this will be equal to integral of 0 to t u dt. Here which is the constant? U is a constant. See, with respect to time, only terms that are related to time can be integrated. So whatever, anything else is a constant. So u outside integral 0 to t dt plus, for at what is a constant? A. T is not a constant because t is with respect to dt. So a outside 0 to t dt. Now I will apply the limits here. So upper limit minus lower limit. So s minus 0 is equal to u into integral of dt is t. Very good. T 0 plus a into integral of t dt is what? T square by 2. T raised to 1 plus 1 divided by 1 plus 1. Limits 0 to t. So now I have integrated all the terms. Now let's do that. S minus 0 is S, which is equal to u into. For t, I substitute t first, and then t becomes 0 plus a into 1 by 2 I can take outside. So t square, first I substitute t minus 0 square. So S will be equal to ut plus half a t square, which is the equation of motion, and I have now derived it using integration. Okay. Is this clear to all of you? Aye, sure. So this is the equation of motion, the first equation of motion. Okay, I didn't derive the first equation of motion, didn't I? Okay. Yeah, I will do that after this. So this is the second equation of motion, students. So I had to derive the first equation of motion, which I didn't. So let's just take this and put it. Hey, what did I do? So I'll just shift it down. Okay. Okay, so this is the second equation of motion. Let's write down the first equation of motion first. I'm sorry, but it's okay. They're all done in different ways, so it's okay. So first equation of motion. So this method is called as the calculus method. Okay. So this method is called as the calculus method. Now for first equation motion, first I'll write down the formula for acceleration. So we know that acceleration is what? Change in velocity by change in time. Okay. It is dv by dt. So the slope of a velocity time graph gives you acceleration. What is the formula for slope? dv by dt. Now I will cross multiply. A dt is equal to dv. So now this will give me the acceleration of a small part. So I have to find the whole thing. So what I do is I'm going to integrate it. Integral of A dt. So minimum velocity. What is the first minimum velocity? Minimum velocity will be u. Maximum velocity will be v. Minimum time is 0. Maximum time is t. So let's differentiate. dv, the integral of dv will be v with respect to u and v, which is equal to, here what is a constant? A is a constant, so I take it outside. Integral of dt. Okay, so now I will apply the limit. So this becomes v minus u. V minus u is equal to a into integral of dt is t. So 0 to t. So v minus u will be equal to a times t minus 0. So this becomes v minus u is equal to at. So from this, v is equal to u plus at. So this is the first equation of kinematics. Okay. Draw shapes, basic shapes. I hope you're understanding this part. Okay. Okay. Now let's take the second part and place it next to this. Here. Okay. So this is the first equation and the second equation using calculus method. Okay, so in the first equation where A is equal to dv by dt, A is a constant. Acceleration is a constant. And yeah, from the second one, we get S is equal to ut plus half at square. Students, do you have any doubts in this part? Anything that you want me to explain once again? Any step that you're confused about or you don't know how that came? Anything? If there's nothing, then we will look at the third one. Let's look at the third one. Yes. Okay. Let's look at the third one. I just gave you a second so you can try it out. Now, the third equation of motion, I'll write it on the next side. So, let me take a different color. This time I'll take green. Okay. So, hi, Sari. Sharmila. Okay, that's Sharmila. Hi, Sharmila. Hi, Aishu. Hi, Samarth. Okay, for the next equation motion, I'm going to take acceleration is equal to dv by dt, something I already know. What I'm going to do is I'm going to multiply and divide this with ds. Okay, ds is displacement, so I'm going to multiply and divide with ds. And what I'm going to take is, I'm going to take this part. What is ds by dt? What is ds by dt? So I take dv by ds, and instead of ds by dt, I will write it as v. Okay, so this is now my formula. It is v into dv by ds. Yes. Okay, is this clear? Yes. Okay, now I have to cross multiply. So ads is equal to v dv. Now I have to find out the integral. So integral of a ds is equal to integral of v dv. What would my limits be? S, it is ds. So the limit should be with respect to s. So the minimum value of displacement is 0, maximum value is s, minimum value of velocity is u, maximum value is v. Is that clear? Hi Neelam, hello. Okay, now I take the constants outside. That also I can do. So a outside, 0 to s, integral ds is equal to v outside, integral uv. No, uv is not a constant. It has to be inside only. It's v dv. So it wouldn't be a constant. V dv. Okay, now let's solve it. So integral of ds is ds. So a s 0 to s is equal to integral of v is v square by 2. So v square by 2 limits u to v. So a into, first I substitute s as s, then I subtract it with the lower limit 0, which is equal to 1 by 2 I can take outside. First I substitute v as v, then I substitute v square as u square. Okay. Hi Chetan, how are you? Today evening I'm not going to take any class, dear. Today Saturday, Sunday, so I'm going to take class in the morning so you can all chill at home in the evening. So this becomes a into s, which is half v square minus u square. So this 2 I take it to the other side. So this becomes 2as is equal to v square minus u square. So I take u also to the other side. 2as plus u square is equal to v square. So now I have the equation of motion, which is v square is equal to u square plus 2as. The very famous third equation of motion. I have this as well. Okay. So quickly students, this is the derivation for the third equation of motion. Is this clear to all of you? Okay. Yes. Okay. Okay. Sharmila says okay. Okay. So these are all the three equations of motion. So you can just take a note of it. All the three equations of motion by using which method? This method is called as calculus method. So now we've done all three methods. We've done graphical method, calculus method and the general method. Now there is one more equation of motion, but the main commonly used one is all three. So if you know all three, I think you're good to go for your first PU. But let's look at the other one as well. Okay, the final one. Okay, just look at that as well. Mr. MSJ, repeat. Which one do you want me to repeat, dear? What is your doubt? Can you tell me what your doubt is? Can you put in a little more detail on what you want me to repeat? Okay. Next is the derivation of equation of motion for the repeat, ma'am. Repeat, ma'am. If you could please tell me what you want me to repeat. That I will repeat. Okay. Is it the first equation of motion or the integration part? Which part? Distance traveled in nth second. Okay, so I'm going to find out the equation of motion for distance travel in nth second. Okay, Chetan does not want repeat. So if you want me to just repeat what I said, you can just watch the recording. Okay, you can just go back and watch the recording. And if it's still not clear, you let me know in the comments. We'll see what we can do. Okay. Okay, so first one. So here, when something is traveling in n seconds, then the time it takes to travel, the time interval is from t is equal to n minus 1 to t is equal to n. Okay, so this is the so this is the time interval. So when something is traveling in n seconds, it's from n minus 1 to n. So let's start the derivation. So first step, we will write down the velocity. So velocity is distance by time, or velocity is displacement by time, and I'll cross multiply v dt is equal to ds. Now what I will do, I will apply the limits. So I will integrate with respect to limits. So what will my lower limit be? It is from n minus 1 to n. So this will be Sn minus 1 to Sn. And velocity will be n minus 1 to n. Okay? Because the time, see, why you might be thinking, ma'am, time is dt, why is it not t minus 1? Because in the question, I'm telling you that time goes from n minus 1 to n. So the minimum value the time can take is n minus 1, the maximum is n. Okay? Now what we can do is we can use Sn minus 1, Sn is equal to, using first equation of motion, V can be written as u plus at into dt n minus 1 and n. So now this is integral of ds Sn minus 1 Sn. This is equal to integral of n minus 1 into n u dt plus integral of n minus 1 n at dt. Okay, So now let's do the math. Integral of ds is what? S. Integral of ds is S. So the limits are Sn minus 1 and Sn. Now this is equal to u is a constant, integral of dt n minus 1 into n plus a is a constant, integral of t dt n minus 1 n. Okay? Now I'll write the next steps on this side so it's easier. Okay? So now, what are the next steps? I will apply the limits. So first I'll take S as Sn, then I'll take S as Sn minus 1. So Sn minus Sn minus 1. Sn minus 1 is equal to integral of u is a constant. Okay, let me not write integral again. I'll just write down the value of the integration. So u is a constant. So u into integral of dt is what? T. So t, what are the limits? N minus 1 and n plus a integral of t dt is what? T square by 2. So t square by 2, again the limits are n minus 1 and n. Okay? So now let's solve it. So Sn minus 1 will be what? Will be Snth. Okay. So how do I put it? So Sn minus 1 will be Snth. I'll just take it as Snth. Okay. U into instead of t, first I should put it as n. Okay. Minus, then t will take the value n minus 1 plus a. First t square takes the value n. So n square. Yeah. N square minus 1 by 2 I take it outside. Okay. Minus, then t square takes the value n minus 1. So n minus 1 square. So let's write it as Snth is equal to u into n minus n. It cancels, isn't it? So this is minus minus. Okay, let me write it down. So this becomes n minus n plus 1 plus Chetan, thank you so much for your concern, but it's okay. Okay, people watch the recorded as well. Alright, so I'll keep taking classes. Don't worry. Minus n square plus 1 minus 2n. This is basically going to be. Yes, I will. Don't worry, Chetan. So now this is going to be equal to n minus n cancels. So u plus a by 2 into n square minus n square gets cancelled. Minus minus, it will become plus 2n. So this will be plus 2n, and then minus minus, this will be minus 1. So if you don't understanding that, I just multiplied minus into n square plus 1 minus 2n. Okay. So this is u plus half a 2n minus 1. So the formula is Snth is equal to u plus half a 2n minus 1. So this is the formula for nth distance travelled in nth second. Okay. So in your PU, even if you don't learn this, it's perfectly fine. I'm just here to teach you everything that's there in the NCERT. I mean, in PU perspective only, but some of you will need extra, right? For those of them, it's for those students. So this is the distance travelled in n second. So you can quickly take a look at this. So you can see here the time travelled is n minus 1 to n. Okay, so I'm just assuming that the displacement between Sn to Sn minus 1 is Snth and I am solving it. I hope this is clear to all of you. So with this, we come to an end of the chapter 1, straight line. Yes, so we've discussed equations of kinematics in all 3 different ways. In all the other classes, we discussed acceleration, velocity, displacement, everything. Okay, so I have done this as 3 sections. So those who are watching only this, there is a first part and a second part. Okay, so all of these 3 together is your chapter fully. Okay, is that clear to all of you? Now, if you want me to do numericals, you can let me know in the comments. I can do a separate video on numericals of this chapter. But other than that, all the theory classes you have, it's there as 3 videos. Okay. Chetan, thank you so much for your concern. Okay. I know what's happening there, and I've been taking classes for some time now. So yeah, that's how it works. Okay, you don't have to worry about that. But thank you so much for your concern. And yeah, those who are watching live, please do. I mean, those who are watching it recorded, please let me know in the comments on how the class was. I would be very happy to know that as well. And if you're looking for offline classes for any kind of an entrance coaching, like your JEE or your NEET or your 8 to 10 foundation, anything like that, if you want classes for anything like that, if you're from Bangalore or from Karnataka, we have a center at JP Nagar. Now, if you're wondering, ma'am, I'm from Tamil Nadu, I'm from Kerala, I'm from Karnataka, I'm from Andhra. Wherever you are, we have offline centers. So you can go to the description box of the YouTube class and you can just check for our centers. Book a visit, go check them out, and I'm sure you will never be disappointed. Okay, you can also look at our channel where we have put testimonies of all our toppers, our JEE toppers, NEET toppers. All of them have come, and so many of our KCT toppers as well. In every live class, I see people coming and telling me, ma'am, I scored this rank, I'm in MBBS, I'm doing that, I'm doing this. So many different things. Yeah. Engineering, medicine, so many different things students are doing, and they keep coming and saying thank you. All that means a lot. So students, if you want to have offline classes or online classes, we are all here. Okay. Hello, it's me, Abhi. The class is over. Okay. Please watch the recording and make sure you come to the next class on time. Is there anything else? If there's nothing else, I think we can wind up. So I'll see you in another class with the next chapter. Okay. Chetan, I understand your words. Okay. I understand. Okay. Thank you for your concern. And we'll have other classes. Okay. Bye-bye.